let's get going. So tonight we are working on the counting principle. And so I have to be honest with you guys, when we did counting principle, which is part of probability, back when I was at school, I did not enjoy this section. Probability, yeah, it was cool, it was fine, nice and easy. But when it came to counting principle, I was like, I don't know what you're talking about. Okay. Maybe my teacher wasn't very good. I don't know. Maybe I wasn't paying attention very well, probably the second one. But the counting principle is really somewhere where you can get extra marks for nothing. If, okay, you practice a whole lot, all right? So you do loads and loads of practice, okay, and you work it out in your own head sometimes. That's the best thing I can suggest for grade 12. Sometimes you can have like 4 teachers explain something to you, but unless you actually understand it in your own mind, that's when it's really going to click. So I would suggest doing a whole lot of extra papers, doing a whole lot of past papers. If you don't already have past papers anyway, guys, I would suggest maybe having a look online. So you can literally Google grade 12 past papers. There's a few different sites you can use. So Eastern Cape has amazing papers. Okay, the Eastern Cape has a website with all the different exam papers on from term 1 all the way to term or your final exam. And then there's also a site, I think it's called Stanley Maths or Stanley Physics. They have some great collection of papers for you to practice as well. So I wouldn't suggest just doing past papers from the final paper. I would suggest doing papers from everywhere. As many different questions as you can get your hands on would be amazing. Okay, so let's have a look at tonight's lesson. All right. We're looking at the counting principle. So first of all, what is the counting principle? Anyone want to give it a try? Anyone want to give a shout out here and tell me what the counting principle actually is? No, we're all good for me to just talk tonight, okay? All right, so again, remember, take notes, take screenshots, but what is the counting principle? So if I'm looking at the counting principle, okay, in mathematics, we begin with counting, hey? So initially we count with our fingers and beans and buttons or whatever it is that they used in class for you guys, or they use like abacuses back in the day, okay? But that's only practical when you have really small numbers. What happens when we have a large number of items which needs to be counted? Okay, so literally we're looking at counting for the counting principle. We're looking at counting large numbers, all right? If we're looking at the official, like fancy definition, then, okay, it's telling us that if there are a number of outcomes in an event. So in other words, they say the following to us. Oh, I hate using red, so I'm just going to change my pen color here if it lets me. All right. So it tells us if there are, okay, so if there are NA outcomes in event A, so if there are a number of outcomes, N of A, outcomes in event A, and N of B, so certain number, we don't know what the number is, outcomes in event B, then, okay, combined, we say the N of A, so the number of outcomes of A, times by the number of outcomes of B. Okay, so that's the fancy way of saying it. All right, so if there's a number of outcomes for event A and there's a number of outcomes for event B, then we combine them and we see N of A times by N of B. So the number of event A times by the number of event B. And that's the fancy way of saying it. Now, the only way to learn probability, and like I said to you earlier on, especially with this counting principle, is to do as many examples as you can. So we're going to look, first of all, at this first example. It says, so I'm just going to leave this here in case anyone wants to take a screenshot while I'm talking. A meal can be made up of as follows. Okay. Choice 1, you get to choose meat, fish, or chicken. And choice 2, you get to choose mash, chips, baked potato, rice, or veg. All right. How many meals can be made up using these choices? Now, If you were in like grade 9 and grade 10, and maybe even the beginning of grade 11, you would have drawn a tree diagram, a decision tree, and you would have seen how many outcomes you get in the end. But guys, that takes a long time. So we're going to go and use the principle that we've learned so far. Okay. We're going to say, to get n of A and n of B, let's call this event A for now. All right, so we're calling this event A. Let's say we call this event B, so using the fancy formula. All right, then that means that if we're looking for the number of choices in A, how many choices do we have here? Meat, fish, chicken? There's 3 choices. How many choices do we have for option B? Mash, chips, baked potato, rice, or vegetable? So 1, 2, 3, 4, 5. 5 choices. So how many different meals can be made up using these choices? We're going to say n of A, so the number of A, which is 3, times by n of B, so the number of B, which is 5, which means we get 15 meals. If you're not sure, and it's a small question like this, it's the starting one, and let's say by some weird like thing of the imagination, you get extra time at the end of your paper, all right, then by all means, go back, test it for yourself. So you'd have start, okay, so you'd start here, then you'd have your 3 options. So what? Meat, fish, and chicken, and then off of each of these, you'd have 5 options. And off of these, you'd have 5 options. And off of these, you'd have 5 options. And altogether, what would you find? You would have 15 altogether. So same thing, exactly the same principle, except now we're using a formula to calculate it, which is so much quicker and so much easier. All right. I'm going to give you guys a chance now to give it a try. Okay. So now, all right, for matric dance, you have the following meal and drink options to you. Okay, so drawing a decision tree for this now, or a tree, or whatever you want to call it, has 4 different options. Can you imagine how huge that's going to be across your page? It's like the ones we got you to do back in like grade 9 when we were really testing your skills here. You're in grade 12. We don't want to do that anymore. We want to use the formula. So you've got starters, you've got mains, you've got desserts, and you've got drinks. I'm going to help you out here in case you can't see your screen really well. Here there are 2 options. Here there are 4. Here there's 3 options. And here there are 3 options. Okay, guys, go give it a try. Go give that a try for me. All right, so the first question asks you how many different meal and drink combinations are available to choose from. All right. Okay, I'm giving you about 30 seconds. I'm going to give you 30 seconds more. All right, let's give it a try. So how many different meal and drink combinations are there available to choose from? What we're going to say, there are 2 starters. Oopsie daisy, sorry guys. There's 2 starters times by, there's 4 mains, there's 3 desserts, and there's 3 drinks. So can you give me answers in the chat here? My calculator has up. Anybody? 72? Are we all good with 72? All trust Awami here? Yeah? Kanye saying yes? Okay. All right. I'm happy. 72. Hey, nice and easy. Miss, this is so easy. But we don't get these ones in class. Yeah, they're coming. In the exam, you're always going to have a nice, easy one. Okay, they do that to you. They give you a nice, easy one. All right. If one of the students is vegetarian, how many meal and drink options would you have? So now I've got a vegetarian. Okay. Remember, vegetarian, they don't eat meat, they don't eat fish, they only eat vegetables. That's vegetarian. All right. In the exam, if they had to ask you that, they would be super specific. They would tell you exactly what that person can't eat. Okay. So let's go give it a go here. So if I've got a vegetarian person, well, then they can have salad. They definitely can't have fried calamari. So 1. All right. For meal option 2, okay, they can't have chicken, they can't have beef, they can't have fish. They can only have the vegetarian option. So 1. All right. Now, if you were being super specific and they weren't allowed butter or they weren't allowed eggs, and then they would tell you what's in everything, we don't know that information. So we're going to leave this as 3. Okay. We don't know what's in the cheesecake. We don't know what's in the brown. We don't know all of that stuff. And finally, well, being a vegetarian doesn't change your drink orders. So 3. So here I'm going to say 1 times 1 times 3 times 3. And now this person has 9 options here, or 9 combinations. All right. Does everyone agree with me? Does everyone know how I did that? We all good? And moving on. Another student is allergic to fish, meaning they're not able to eat the calamari or the fish main. How many options does the student have? So now we're allergic to fish, hey? Well, if I'm allergic to fish, okay. All right. Let's go see. If I'm allergic to fish, I can't have fried calamari. So 1. I can have chicken. I can have beef. I can't have fish. I could have vegetarian. So 3. Nothing in the desserts that includes fish. So 3 and 3. Okay. So I'm going to have 1 times 3 times 3 times 3. And that gives me 27 options. Okay. All right. So we've done that together. Okay. Now you're going to try for me. All right. So a gift pack can be made up as follows. Choose 1 CD out of a possible 4. So you got 4 CDs. Choose 1 packet of chips out of a possible of 5 different flavors. Choose 1 chocolate out of 12 different types. Choose 1 type of drink out of a possible 3 types. How many different gift packs can you make? All right. I'm not giving you long here, guys. I'm giving you like 2 minutes max. Okay, go try that out. Using the rules that we just did now. Go give that a try. Okay. Got about 1 more minute left. All right. Okay, let's go have a look. So I've got 4 different CDs. So I hope that on your page that you guys have got written out, or your book that you've got for Teacher Sam, right, that you're writing 4 times by 5 different flavors of chips. So 5 times by, for choice 3, 12 different types of chocolates. And for the drink, 3 different drinks. All right, grab those calculators for me, or give me the answers that you guys got, please. Because like I said, my calculator, I'm busy operating on my cell phone, and that's not great. Nice, well done. 720, amazing. Okay, so 720 different gift packs can be made up. Okay, 720 different gift packs. All right. Oh, okay. So let's try another example together. Right. Consider the word equation, guys. So I just need to fix this one guy here for you because he is not right. Okay, so you guys look at it in the meantime. Consider the word equation. Okay. How many possible word arrangements can be made up if, all right, how many possible word arrangements can be made up if the letters may be repeated? So how many possible word options can I have if I'm allowed to repeat letters? Okay, so again, this is one of the questions that I didn't like to do because, my teacher, I didn't understand what they're talking about. And this is one of the ones where I say to you, it's really good for you to work out on your own how to understand this. I'm going to teach it to you how I understand it. But again, remember, all right, every single person is different. Every single person has their own understanding. So let's give it a try. Okay, so I have the word equation, all right? I may repeat the letters. Okay. So if I'm looking at the word equation, how many letters are in the word equation? Well, if I count them up, okay, it gives me 8. There's 8 letters altogether. Okay. Now, fortunately for you guys, you've got these beautiful calculators. Okay. And you know that if I've got 8 possible letters, that means that in each of the spaces, so 1, 2, 3, 4, 5, 6, 7, 8. So in each of those spaces, okay, how many possible options do I have? So here's space 1, space 2, space 3, space 4, space 5, space 6, space 7, and space 8. Right. If I have 8 letters altogether, and there's 8 placeholders altogether, guys, how many options do I have for space 1? So how many letter options do I have for space 1 altogether? What's the total number of letter options? Good, Awami. Nice. Okay, I have 8 possible options. I have the E, I have the Q, I have the U, I have the A, I have the T, I have the I, I have the R, and the N. Okay. If I'm looking at option 2, well, they're telling me the letters can be repeated. So if I really wanted to, I could have E. I could repeat the letters as many times as I want. All right. So that means that in space 2, how many options do I have? I still have 8. In space 3, I have 8 options because I have 8 letters. In space 4, I have 8, 8, 8, 8, and 8. So that means what? It means that according to the counting principle, okay, I can either write it as follows. I can say 8 times 8 times 8 times 8 times 8 times 8. 1, 2, 3, 4, 5, 6 times 8 times 8. So I can write it that way, okay? All right. Or I've got this magical button on my calculator, okay? It's the function button. So the raising a power to a power. It's the same thing as saying 8 to the power of 8. All right. Guys, calculators, what's 8 to the power of 8, please? Put that in on your calculator. What do you get? 8 to the power of 8. It is a very large number. All right, nice. Well done. Okay, so 1. Good, nice, guys. 6, 7, 7, 7, 2, 1, 6. Well done. Okay, now what happens if the letters cannot be repeated? All right, so what happens if the letters now can't be repeated? So I've got this whole thing. I've just calculated my first one. It was beautiful. Now they're saying to me the letters can't be repeated. Okay. So when the letters can't be repeated, what do we need to do? We need to arrange 8 unique letters. In other words, if I use the E, I can't use the E again in the second space. If I use the Q in the second space, I can't use the E or the Q in the third space because I've already used them. All right. So the total number of arrangements of 8 unique letters, all right, we can either go and we can work it out. So we can say to ourselves the following. So we can say, well, this is now space 1, 2, 3, 4, 5, 6, 7, 8. Okay, and some people like to do this each time. They like to tell themselves, in space 1, I've got 8 letters I can use. In space 2, I've used one of the letters now, so I've got 7. In space 3, I've used 2 of the letters now, so I've got 6. In space 4, I've used 3 of the letters now, so I've got 5. In space 5, I've used 4 of the letters now, 1, 2, 3, 4. So I've got 4, 3, 2, and for the last one, I only have one option because it's whatever I haven't used last. All right. So that's one possible way to do it. On my calculator, I go say 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's completely okay to do. Okay. But if you want to do it faster, you're going to say to yourself 8, and you're going to press your factorial button. It's that one with the exclamation mark. So 8 and an exclamation mark. Okay. 8 exclamation mark tells me when I do that, or when I say 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, I get 4, 0, 3, 2, 0. Right. Do you guys agree with me? Are my calculations right? These are in my head, so it might be a problem. Yes. Okay. Thank you, Oami, keeping me sane here. Thank you. I'm not talking to myself. Okay. Cool, guys. All right. Now, okay, I changed it around a little bit because the second letter must now be an E. Okay, and the last letter must now be an N. All right. So the second letter must be an E, and the last letter must be an N. Okay. Which means in the remaining 6 positions that I've got, so let's go do them. Let's go draw it out so it makes sense for ourselves. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8. Okay. It doesn't say, guys, it doesn't say anything about using the number letter once or repeating it or, okay, but it says what? It says that this letter over here, okay, the second letter has to be an E. So I only have one option here. All right. And it says that the last letter, it has to be an N. So I only have one option here. Okay. If I've taken E and I've taken N away, if I've taken E and I've taken N away, now they haven't said to me the letters may not be repeated, but in the previous question they did. So I'm kind of assuming now that I can't reuse the letters as well. Okay, so that's one thing. All right, and I've already used E and I've used N. So out of the total letters of 8 for equation, right, how many are left? I'm going to say 8 minus the 2 that I'm not allowed to use. In other words, for the first space, I can have 6. Then I have to put that letter in space 2. For the third space, I've got 5 options. Then I've got 4 options. I've got 3 options. I've got 2 options. I've got 1 option left because in the 8th space, I have to use the N. Okay, I have to use the N. So on my calculator now, I can go say 6 times 5 times 4 times 3 times 2 times 1 times 1 times 1. All right, that's absolutely possible. Okay, but actually, what's that the same thing as saying? That's the same thing as saying the following. It's the same thing as saying, well, I've got 6 factorial. Why? Why 6 factorial? Because timesing things by 1 not going to make a huge big difference. Okay, so how many possibilities do I have? I've got 720. Okay, check me, make sure I'm right. Yes, thank you guys. Awesome. Okay. I hope we're all good. I hope we're all together. I really hope this is making sense. Okay, let's have a look at another option. All right. Oh, driving to school, this one. They love this question. Love to talk about either driving to school or catching the bus to school, on the train. So every morning, a parent must drop their child off at school on their way to work and pick them up again on their way home from work. Okay. There are 3 different roads from the parent's house to school, right? And 5 different roads from the school to the parent's work. In how many ways can the parent travel from home to work? Okay, how many ways can a parent travel from home to work, guys? Okay, go give it a think. All right. So, first of all, they're not going straight from home to work. Where are they going? They're going from home to school. All right. And from home to school, there are 3 different roads. And then they're going from school to work. And from school to work, there are 5 different roads. All right. So it's back to being one of those nice, easy ones, just lots of words. So a little bit of maths lit here, having to determine what the maths is in the words. So I've got 3 times by 5, and 3 times 5 gives me 15 different options. Okay, nice, well done. Nice, guys. Okay, now it says to travel from their home to his work and then back to their home. Again, remember, what's happening here? Are we going straight from home to work? We got to stop over. We got to stop over at school first. Okay, we got to stop over at school first. So let's go do the calculations. I'm going home to school. That's 3 options. I'm going school to work. That's 5. Now I must go backwards here. I must go work to school. Okay. And that gives me 5 options again. And then I must go, all right, school to home. Hey, and that gives me 3 different options. So 3 times 5 times 5 times 3. Okay, 3 times 5 times 5 times 3. Well done. 225 options. Okay. Right. In how many ways can the parents travel from their home to their work and back to their home, okay, if they don't use the same road twice? Okay, they're not going to use the same road twice. So I'm going to write it out here for you. So you've got home to school, school to work, work to school, and school to home. Okay. They don't want to use the same road twice. They don't want to use the same road twice, guys. Give it a think. Think about it. It's tricky. It is tricky, but you got this. Okay. Let's have a look. So home to school, 3 roads here. School to work, 5 roads. So I get in my car in the morning, I've got all 3 roads, and then I leave the school and I've got 5 roads. All right. Now I need to go back from work to school. And on the way there, I saw there was an accident on the road, one road. So I'm not going to come back on that road again. So I had 5 options. Now I'm only going to have 4 options. And from school to home, oh, actually, I really like to drive past the beachfront and see the sea on my way home. So I'm going to cut that one option out that doesn't have that. So I've got 2 options left. All right. So 3 times 5 times 4 times 2. Absolutely right. 120 options. That's crazy. Okay. That's absolutely crazy if you think about it. All right. Absolutely crazy. Okay. All right, so we had a nice little easy one there, little break, little mind break. Okay, let's have a look at the next one. So now you're going to try all by yourself. A password is to be made up and using the format XXXYY, where X represents any digit from 0 to 9 and Y represents any letter of the alphabet. How many different passwords can be formed if A, the digits and numbers may be repeated, B, neither the digits nor the letters may be repeated, and C, the digits may be repeated but not the letters? Okay, So A, you can repeat everything, doesn't matter. B, okay, you can't repeat anything. And C, you can repeat the digits, the numbers, but not the letters. It's a trick one. I'm just putting it out there. There's a little trick. Okay, so there is a little trick. Okay. All right. I hope that you are trying. I hope you've got your paper out and your pen out and you've taken a screenshot of the question. Okay. All right, guys, let's go have a look. So, okay, let's go have a look. I'm going to start by doing the digits. All right. So if I'm looking at the digits 0 to 9, okay, be careful. There's a trick there. All right. Students often fall for it. Digits 0 to 9. That means I've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many options do I have? Yes, it's 0 to 9, but how many options do I have? I have 10 options. So if I'm looking here, okay, if I've got the X's, so there are 1, 2, 3 spaces for the X's and 1, 2 spaces for the Y. So X1, X2, X3, Y1, and Y2. Okay, for A, I'm allowed to repeat them. I can do whatever I want. Okay, so for A, right, 0 to 9, I have 10 options. But for X2, I'm allowed to repeat them again. So 0 to 9, I have 10 options. 0 to 9, I have 10 options. All right. Okay, and the letter Y represents any letter of the alphabet. How many letters are there in the alphabet? How many? You need to know this for your maths exam because they might ask you, or you can sit there counting. Good, Wami, there's 26. So 26. Okay, and then I'm allowed to choose them again, so 26. So for A, what am I going to have? I'm going to have 10. You can say to the power of 3, or you can say 10 times 10 times 10 times 26 times 26. And when I calculate that, it gives me what? Good. 6, 7, 6, 000. Be careful. Be careful in the maths exam. Make sure you're writing down all the digits. All right. Okay. B. Now it's saying to me, nothing can be repeated. Okay. So now it can't be repeated. Hey? So let's go check it out. All right. So if it can't be repeated, okay, the first time I pick my numbers, I've got a choice of 0 to 9. So for the first number, I've got 10 options. All right. For the second option, I've got choices. 0 to 9, but I've already put 1 as the first one. So actually, I only have 0 to 8, which means I only have 9 options. And then for the third one, I'm only going to have 8 options. Okay, looking at my letters, what's happening with my letters? I've got 26, and my second option, I'm going to have 1 less, so 25. So I've got 10 times 9 times 8 times 26 times 25 is going to give me, yes, well done, Leila. Nice, click off the mark. Good, Oami. So 468 000. Well done, guys. Okay. See? Now what can happen? Now the digits may be repeated, but not the letters. So the digits can be repeated, but not the letters. So if that's true, all right, I'm allowed to repeat the digits. So 10, 10, 10 options, but I can't repeat the letters. So 26 and 25. Hey? So 10 times 10 times 10, or 10 to the power of 3, times 26 times 25. Absolutely correct, guys. You get 650 000. Okay. I'll give you a minute just to take, or literally 10 seconds, just take a screenshot if you need. Okay. All right. Next one. In how many ways can 7 people fill 10 vacant seats in a movie theater? So there's 10 vacant seats. How many different ways can 7 people fill up these seats? Ugh. Okay. We got this. We got this. All right. So if we're going to determine the number of different ways that 7 people can fill up 10 vacant seats in a movie theater, we need to consider the fact that we are choosing 7 seats out of the 10 available seats, okay, first of all. And then we're arranging the 7 people in those 7 chosen seats. Whew, okay, that's a lot to think about. All right. So when we do that, we're going to have the following, hey? We're going to say to ourselves, okay, the number of ways to choose 7 seats from 10 can be calculated using a binomial coefficient. All right, so we're going to have a fraction, in other words. Okay, we're going to have a fraction, in other words. And when I do these ones, this is how it works in my head, how I think of it. Okay, guys, you can do it however you want, but this is how I think of it. I'm telling myself there's 10 seats available, and you'll see I'm not using any kind of mouse. This is like my scratchings on my paper. And I've got 7 people. So I've got 10 seats. I've got 7 people. Okay. All right. So that means if I'm looking at that, all right, it means what? It means that I've got 10. Okay. 10 times 9 times 8. All right. I've got 3 options in the bottom. 10 times 9 times 8. All right. Because those are the 3 ones that are available over 3. Whoopsie. Sorry. Sorry, guys. So this is one way to write it. Over 3 times 2 times 1. Why am I saying 10 times 7 times 8? Because I had 10 on the bottom, on the top, sorry, 7 on the bottom, all right? So 10, how many am I left over with? 10 minus 7 is 3, and that gives me 120. Now there's another way to calculate this that you may have been shown in class, and that's also, if you understand that way, amazing, well done. This is the way that I've got it in my head. You don't have to do it this way. You can do it the way you've been told in class. So in class, you may have been told the following. You may have been told on the top, I'm going to have 10 factorial. Okay? And on the bottom, what am I going to have? I'm going to have 7 factorial times by my 10 in total minus my 7 that I've already taken factorial. So in other words, 10 factorial over 7 factorial times 3 factorial. Okay. Of course I can explain it again. Of course I can explain it again. All right. So I'm going to start with how I understand it. Okay. I'm going to start with how I understand it again. All right. So I've got 10 vacant seats. I've got 7 people to fill them. So in other words, I'm putting my options on the top. So how many spaces? Remember, if I was drawing it, I would have like 10 different spaces there. Okay. So in other words, I've got 10 seats, but I only have 7 people to fill them. So I have 10 seats. I only have 7 people to fill them. Okay. What am I going to do? All right. So that's telling me, okay, 10 minus 7, guys, is 3. 3 is going to be my key number here. 10 minus 7 is 3. 3 is my key number. I think I left that one out the last time. All right. So I'm going to definitely do a fraction here. I'm going to definitely do a fraction. So the way I understand it is I'm starting on the top. I have 10 times 9 times 8. Do you see how I've got 1, 2, 3? 10 times 9 times 8. Okay. Over. On the bottom, if I say 10 minus 7, it gives me 3. So I'm starting with 3 times 2 times 1, and that gives me 120. Okay. But another way to do it, all right, another way to do it, and the way you may have been taught in class, that's the way I understand it. You don't have to use that way, okay? The way that you may have been taught in class is the following. 10 factorial over, okay? How many people do I have? So that's the number of options, 10 factorial over 7 factorial, all right, times by 10 minus 7 leaves me with 3 factorial. Okay, if I go do it the long way on my calculator, because I need to do that because obviously mine is broken, on the top, I'm going to have 3, 6, 2, 8, 800. On the bottom, I'm going to have 7 factorial 5040 times by 3 factorial 6. Okay, put that in your calculator for me. Put this huge big number. Just going to scribble on my side here, guys. 3240 3 628 800 divided by 30240 gives me 120. Okay, let's look at the maths. Why are those two the same? Why is it the same? Why is it that Mam's quick way of doing it got the same answer as the other way? All right, that's because if we look at what 10 factorial is, so in other words, okay, you have 10 movie seats, right? You have 10 movie seats. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In those 10 options that you have, so on the top, you've got 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So those were my top options. Okay, that's how many seats I have. That's the way you can arrange them, whatever you want to do. All right, times by. On the bottom, what's happening? Okay, I only have 7 people, and those 7 people can be arranged 7 different ways. Hey, so 7 times 6 times 5 times 4 times 3 times 2 times 1. All right. And then I have 3 leftover seats. 3 leftover seats. So there can be like a gap between the first and the second person. There can be a gap like the 6th person. It can be anywhere. So 3 times 2 times 1. Well, mathematically, Okay, what's happening? 7 cancels out with 7, 6 cancels with 6, 5 with 5, 4 with 4, 3 with 3, 2 with 2, 1 with 1. So what am I left with? 10 times 9 times 8 over 3 times 2 times 1, which gives me 120. Let's look at a different way. Okay. Take a screenshot if you want. That's a tricky one. That's a tricky one. And they always do it. Waiting in line to get your driver's license. Sitting in your final assembly. All sorts of things, guys. At the doctor's office. Okay, at the doctor's office. Right. So let's look at this one. Determine the number of ways that 10 athletes can be awarded first, second, and third place in the 100-meter sprint. So again, a little bit of maths lit here. Okay, trying to work out the numbers. All right. Determine the number of ways that 10 athletes can be awarded first, second, and third place in the 100-meter sprint. All right. This one is not actually as hard as what you think it is. Okay. There's only 3 options here. There's 1, 2, 3 options. Go give it a try for me. Go give it a try. And while you're doing that, I'm going to pull 1 or 2 more examples for you while you're doing that. One of these ones that have like sitting in a chair and that kind of thing. Okay. Oh, dear. Sorry, guys. No. What is happening here? Okay, let's bring this back to where you were. Apologies, and bring it back to the question for you. Don't know where the question went. Oh dear, messing up Teacher Sam's board here altogether. Okay, let's go back up to Teacher Sam's page. Right, apologies, everybody. There we go. So we're back up to the question for you. There you go. And I'm going to paste this one in here for you. So this one we're going to try after you're done with that one. Okay, nice. I like that you're calculating it. Well done. All right. Ooh, getting some nice ones here for you. Okay, so well done. I see some people are trying. Can you? Well done. So determine the number of ways that 10 athletes can be awarded first, second, and third place. So there's only 3 places. Well, for my first option, I'm going to have 10 people. Okay, so it's a possibility that 10 people could be in that first place. For the second option, then there'll be 9, and then there'll be 8. So 10 times 9 times 8, well done, gives you 720. Okay, well done. All right. A group of friends plays 10 soccer games. For each game, there are 3 possibilities: a win, a draw, or a loss. What are the number of possible results for those 10 games? Okay, what are the number of possible results for those 10 games? All right, should be nice and easy now, that one. Okay, it's not telling you that for the first game it has to be this and the second game it has to be that. It's a nice, straightforward one. Okay, while you're calculating that one, I'm going to give you another one, if it'll let me. There we go. Okay, let's plug this one in for you. Oh, and it disappeared. Sorry, guys. Made my question disappear. Okay, let's finish this one first. All right, so we're playing 10 games. There's 3 options. What are we going to do? So we've got 10 games. Okay, 3 options each time. What's happening? In other words, if I'm looking at this, I would have 10 spaces here. Hey, 1, 2, 3, 4, 5, 6, 8, 9, 10. Okay, my 3 options. For my first game, I can win, draw, or lose. 3. My second game, I can win, draw, or lose. 3, 3, 3, 3, 3, 3, 3, 3. So in other words, I'm going to have 3 to the power of 10. And what's 3 to the power of 10? Good. 5, 9, 0, 4, 9. Well done. Nice. Okay, do we have time for another hard one? All right, do we have time for a hard one? Let's see. Insert picture from my file for you guys. Let's do this one. I quite like this one. Saying it's hard, but it's not hard now because we know the trick here. All right, so a gym card, all right? A gym card has a 4-digit PIN, okay? The 4 digits can be repeated, and each of them are chosen from digits 1 to 7. All right, what are the possible options? Okay, what are the possible options? All right. Okay, so I've got 4 digits, guys, again. 1, 2, 3, 4. I've got the numbers 1 to 7 to choose from. So how many digits do I have to choose from? 1, 2, 3, 4, 5, 6, 7. 7, hey? So my first one, I'm allowed to repeat. So 7. My second one, I'm allowed to repeat. So 7, 7, and 7. So 7 to the power of 4. What does it give me? 2, 4, 0, 1. Do you all agree? Nice. Well done. Well done. Now, let's add an extra onto that. Let's add an extra little bit onto that. Okay. Well, number 2. All right. Let's add an extra little bit onto there. I'm going to say to you, okay, what is the probability? All right. What is the probability that I guess right on my first try? What's the probability? Okay. And let's put it in here for you. All right. So what's the probability of guessing the first digit, okay, correctly on the first try? What's the probability of guessing the first digit correctly on the first try? Okay, I'm going to give you a hint. All right. You need to give your answer as a common fraction. So give your answer as a common fraction. What fraction? All right. Wami's got one answer for me. Okay, anyone else? Awami, well done. You are right. The probability of you guessing correctly on the first try, well, you're going to put any number into there, hey? So What's the probability of guessing the first digit correctly on the first try? It's going to be 1 out of 7. Nice. Well done. All right. Grade 12s, you guys have done so well.